Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at information on inverses, specifically inverse trigonometric values, as we are preparing for our Chapter 2 test, Part 2. So what I've done is I have a pre-test here for those individuals who are not part of my students in class. What I'd like you to do is just take a moment and take a screenshot of the first 8 questions, please. I'm now going to give you the second 2 questions. Please take a screenshot. And then finally, we have graphing, where we are graphing a secant, cosecant, tangent or cotangent, sine or cosine. In this case, you'll notice we have a cosine here. And then we're going to graph a secant. Alrighty, here we go. So the first part of your information for this chapter is just working with our basics of arcs. Now we know that an arc sine is only going to be in quadrant 1 and quadrant 2, quadrant 1 and opposite of quadrant 1. Cosine will be in quadrant 1 and quadrant 2, and a tangent will also be in quadrant 1 and the opposite of quadrant 2. So that's negative pi over 2 to pi over 2, negative pi over 2 to pi over 2, and 0 to pi. So when we're looking at the arc sine, we know that the reference angle for the arc sine, being root 2 over 2, is a pi over 4. In the first quadrant, the reference angle is theta prime, or is theta. Therefore, the answer to this is pi over 4. Unlike other functions where we see sine of theta equals root 2 over 2 and has 2 answers in the first and the second, arc sine has a restricted domain and therefore only negative pi over 2 to pi over 2. Cosine being positive 1. Cosine is positive 1 at 0 pi. Since the domain of arc cosine is between 0 pi and pi, 0 pi is an acceptable answer. Going to number 3. Here we see a negative sign. Now, we're going to use our reference angle again, and just think about the arc sine, or when is sine going to be root 3 over 2 in the first quadrant. This is a pi over 3. Now, we therefore have in the negative first quadrant, negative pi over 3. Another way to do this is to use your even-odd identity to factor out the negative, then find the arc sine of root 3 over 2, and multiply by the negative that's outside. Once again, that answer is negative pi over 3. Arctangent going to 0, or arctangent of 0. This can only happen at 0 pi. Now you have to remember that on the test that you're going to take, I'm going to give you 4 very straightforward reference angle problems. You just have to remember the domain and be able to find the correct value. This brings us to numbers 5, 6, 7, and 8. Now, number 5 is asking you to first work with the sine of 0. Sine of 0 is 0, and therefore I'm looking for the arctangent of 0. And the arctangent of 0 is 0 pi. Once again, you can call it 0 if you'd like, or you can write it as 0 pi. Notice now we have our arc first. So our arc being 4/5. I'm going to need to stop and think about this, and I'm going to put this into my reference triangle. Putting my right triangle and my theta in the first quadrant, since the arc sine is a positive, I would put it in the negative first quadrant, therefore down here, if it were a negative. We have 5 is our hypotenuse according to the ratio. Sine is opposite over hypotenuse. That means the opposite is 4, And because this is a 3, 4, 5 triangle, I can put a 3. I can also work with 25 minus 16 to the square root, and that will give me the square root of 9 for 3. That's using the Pythagorean theorem. So I'm now looking for the cosine of this theta in this triangle, and the cosine of this angle is going to be 3/5. My answer is therefore 3/5. We're now going to go to the arcsine of the cosecant of negative pi over 2. Now the cosecant of negative pi over 2 is negative 1, and so we have the arcsine of negative 1. But now we're talking about the arcsine, which cannot be in the second, third, or fourth quadrant. It can only be in the first or the opposite of the first. So factoring out the negative again, so that I'm looking at the negative arcsine of 1, I now have negative pi over 2. Negative from the negative out in front, and then pi over 2 for our answer. We're now going to number 8. Notice number 8 gives me 11/17. It's not our standard triangle. It's not a 3, 4, 5 triangle either. So I'm going to set it up. Cosine is the adjacent over the hypotenuse. So I'm looking for this middle piece, and I'm going to be working with the Pythagorean theorem. When I do, I get 17 squared minus 11 squared, and I end up getting 168, I believe. And that was square root of 4 is 2, root 42. Okay. So once I have my answer there, I can now set up my ratio. The cotangent ratio is the adjacent 11 over the 2 square root 42, and I have to move my radical to the top. It's going to leave me with 2 times 42, and I'll have an 84 in the denominator. So my answer turns out to be 11 root 42 over 84. This brings us to numbers 9 and then 10. Number 9 is asking us to follow the same procedure that we did in the previous 8 questions. However, we're going to be using the second process for 5, 6, 7, and 8, where we have 2 functions. So I'm going to set up my right triangle first for the arcsine. And the arcsine is the opposite over the hypotenuse. That means that this piece down here has to be 4 minus the square of x plus 1. Now, I'm not going to go ahead and FOIL that out and add like terms, although I could. But there's no reason to. All we want is the cosine ratio, and the cosine ratio is our adjacent over hypotenuse. So that's going to give me the square root of 4 minus x plus 1, the quantity squared, divided by 2, and that's the answer we're looking for right there. Number 10. Same basic concept. Now, in order to find the radian measure, we are going to have to use our calculator, but everything else can be done, and we are looking for the exact values. So I'm going to start off with my triangle and look at what quadrant it's in. Cosecant is positive in the first and second quadrant. Cosine is positive in the first and the fourth, so the triangle has to be in the first quadrant. Setting up the triangle and using my cosecant ratio, which has the hypotenuse over the opposite. And that means that I'm looking at the square root of 80, which would be 4 root 5. And I'm now ready to start finding all of my values. Since we already know the secant, I'm going to go ahead and start with my sine of theta. The sine of theta is going to have to be 1 over 9, the reciprocal of the cosecant. The cosine is going to have to be 4 root 5 over 9, and the tangent is going to have to be 1 over 4 root 5, which means that I'm going to have to move my radical to the top and multiply by 4 times 5. Our secant will also have to be adjusted for the radical in the denominator, as we will have a 9 over 4 root 5. This will give me 9 root 5 over 20. And then I go to my cotangent, and the cotangent of theta is going to end up being 4 root 5 over 1. Now the last thing I have to do is use my calculator to find this angle theta. And I'm going to use my arc sine since it's a positive. If I had a negative, I would use the cosine. Now we are looking for our ratio in radian measure, or our angle in radian measure. So I'm going to go ahead and put my calculator down so that you can see what I'm doing. I'm going to go ahead and I'm going to put the sine of 1 divided by 9. Let's try that again. We need the arc sine. The arc sine of 1 divided by 9, since this was a ratio. I then hit enter, and you'll notice my answer is right there, 0.1113. And that's the answer to that question. And we can now go to number 11 and the graphing portion of this. I hope you're doing okay. Here we go. So when we're graphing, please remember, I equate my values when I need to. In the first question, all I'm having to do is identify and answer basic questions. So for example, what's the amplitude? The amplitude is 1/6, and I'm going to write that down. The amplitude is 1/6. Now I can say the amplitude is a length of 1/6 as well, and that is technically more accurate, just like the length of a period. So when I do the period, I have this 5, and I'm going to just take a moment and factor out the 5 so I can see the phase shift. Remember, when you factor, it's an act of dividing. So I can see my phase shift is going to be a length of 3 pi over 20 to the left. My period can now be identified very clearly as 2 pi divided by 5. So let's just write that down now. The period is a length of 2 pi divided by 5. The phase shift is a length of 3 pi over 20 to the left. Notice our center line, or what we could call our midline. Yeah, center line or midline. This is lowered by 2. Often we describe our vertical shifts as down, which would be acceptable. I'm going to just describe it in terms of that center line or midline, okay? So the midline or center line is lowered or dropped by 2. All right. The equation of the center line is y equals -2. Then we have the domain. The domain is all real numbers. The range is. Now we know it's in between 2 values, so we're going to take our center line -2, and we're going to subtract 1/6. That's going to give me -13/6. So I'm going from -13/6, and then I'm going to take that center line -2, and I'm going to add 1/6, and I'm going to have 11, -11/6. There's my center line. Now the last thing I ask is, what is the left endpoint of your cycle? That means I'm equating 0 pi. So I'm going to take a moment and I'm going to set this equal to 0 pi. I'm going to find out what it is. And I find out that the x value of the leftmost endpoint is going to end up being negative 3 pi over 20. This is just for one cycle. So I'm going from 0 pi to 2 pi. Okay, I equate 0 pi, I equate 2 pi. When I equated the 0 pi, the x value of the left endpoint is negative 3 pi over 20. And then I'm going to equate it to 2 pi. So if I set this equal to 2 pi, so I'm going to divide by 5, and then I'm going to subtract 3 pi over 20. I end up getting pi over 4 as it reduces. So I'm going to write that down. The x value of the right endpoint of the cycle is pi over 4. And I now have everything, and I'm ready to move on. Now, what's important to remember is that when we're doing these words, these sentences, we're describing what's on the graph. So that in this next part, we're going to graph, right? And you'll notice I have a brand new equation. So I'm going to go ahead and I'm going to graph this one. And just as I did in the previous, I'm going to equate it to 0 pi, and I'm going to equate it then to pi over 2. And when I equate it to 0 pi, I find that the 0 pi occurs, and keep in mind we're setting it equal to 0 pi equals this theta divided by 4 plus 3 pi over 4, and I find that I get negative 3 pi. I then do pi over 2 equated to theta divided by 4 plus 3 pi over 4, and I find that I end up with a negative pi. So I now have how far I need to go, and I'm ready to start graphing my cosine. I'll put down my my x-axis. Let's go ahead and put a y-axis in. Give ourselves some room. We're going to go up 2, 1, 2, and then we're going to go up 3 from there. 1, 2, 3. So I'm all the way up here at 5. I'm going to drop 1, 2, 3 to negative 1. Center line goes right in the middle. I'm always going to identify it, y equals 2. I'm now going to locate my negative 3 pi and negative pi. So if this is negative pi, then I have 1, 2, so negative 1, negative 2, negative 3. So I now have negative 3 pi, negative pi, positive pi, and positive 3 pi. And continuing one more to get a full cycle, I now have 5 pi. So we know halfway in between, and we're just go ahead and plot some points, whatever it takes. So if I decide to put negative 3 pi into this, I get negative 3 pi over 4 plus 3 pi over 4. This is the cosine of 0, which is 1. 3 times 1 is 3, plus 2 makes 5. And right here at 3 pi, negative 3 pi, I am at 5. Plot my point, and everything now follows. All I have to do is keep going up and down, and then I'm going to draw my cosine. Now I like to turn my page so that I can get this in a nice smooth. Let's make sure I've done this correctly. It looks like I've got my point the wrong place. That was quite silly, but I'm glad I did that. It just shows you that we can be doing this for years and still make a silly mistake. You'll notice I needed to go down to my center line, and then I needed to go back down, then to my center line, and back up again. Now I can plot my graph and graph it. I do have to plot the points, label these points on my graph. So let's put negative 3 pi, comma 5. This would be negative pi, comma 2, pi, negative 1, 3 pi, comma 2, 5 pi, comma 5. And there's my graph. Woohoo! Last thing we have to do is graph this secant. We're doing the exact same thing. I'm going to equate values. So unlike the cosine and sine, where I equate values straight across, I'm working with asymptotes. So I'm going to take my 2 theta plus 2 pi over 3, and I'm going to set it equal to pi over 2 plus pi k. Now, if I were doing a cosecant or cotangent, I would be equating it to pi k. So I'm now going to solve, and as I do, I end up finding that my theta is going to end up being negative pi over 12 plus pi over 2k. So I'm going to find some asymptotes now. The first one, when k equals 0, is negative pi over 12, excuse me. When I put in a 1, I'm adding 6 to give me positive 5 pi over 12. And if I add 6 again, I have 11 pi over 12. So these are the 3 asymptotes that I'm going to work with. Center line is up 1. Then I have an amplitude of 2, so up 1, down 1, or up 2, down 2. Going between 3 and negative 1 now. I'm going to put in my negative pi over 12 and then add 12, a total of 12 of them as I go across. So here's my negative pi over 12. 1, 2, 3, 4, 5, 6. There's the next asymptote. 1, 2, 3, 4, 5, 6. Drawing my asymptotes straight up and straight down. I'm going to have to label these asymptotes and the center line now. Here we go. Theta cannot equal negative pi over 12. Theta cannot equal 5 pi over 12. Make sure you can see this. And then theta cannot equal 11 pi over 12. The center line is at y equals 1. And I'm now going to locate a point somewhere in between. So if I'm sitting here at negative pi over 12, I'm going to go 3, halfway. 1, 2, 3. Notice that I am at 2 pi over 12. 2 pi over 12 is going to give me pi over 6 as my first value. So when I graph this, I'm going to start at pi over 6, and I'm going to plug that in right here. Now you'll notice when I do plug it in, pi over 6 times 2 is pi over 3. 1 pi over 3 plus 2 pi over 3 makes 3 pi over 3 for 1 whole pi. And we know the secant at pi is negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 1 makes negative 1. And right there is my first point at pi over 6, negative 1. The next point is going to have to be 3 across, and it's going to be up here. And I find this to be at 2 pi over 3, comma 3. I have my asymptotes identified. I have my center line identified. I have my points identified, so I can now draw my curve. Always draw away from the center line. If you cross the center line, you've done it wrong. You'll need to start all over again. That can be frustrating. So here's my graph. Now the last thing they ask me to do is state the vertical asymptotes. So the vertical asymptotes are theta equals, and now I'm going to put this information in, negative pi over 12 plus pi over 2k, such that k is an element of the integer set. Then I'm going to have to find my domain. The domain is theta is an element of the real number set, double barred r, such that theta cannot equal negative pi over 12 plus pi over 2k, such that k is an element of the integer set. Make sure you see that. That's my answer right there. All I have left is the range. And the range is going to be from my lowest, which is negative infinity, going up to that negative 1. Then there's a gap, which I'll put a union for. I'm starting at 3, and I'm going to positive infinity. So there you go. This is what we're doing on the test. This is what it will look like. And I've tried my best to give you clear and direct information so that if you need any or have questions, that this can answer them. Please remember, if you still have questions after watching the video, you should come in and get help at lunch. If you liked this and found that it was useful, please click like. Thank you very much. Have a very good and safe evening and a wonderful weekend. Take care, be safe, be well. Cheers. Bye-bye, Hornets.